Hi there, in this video you're going to learn about scale drawings and models. To start with, you need to know what a few words are before we move on to doing some math with the scale drawings and models. The first word that you need to know is what a scale is. So a scale is the relationship between the measurements on a drawing or model and the measurements of the real object. So oftentimes you'll see a scale on the bottom of a map where it'll say something like 1 inch is equal to 1,000 miles. The scale factor is the ratio of the length on a scale drawing or model to the corresponding length on the real world object. So this is now the scale but written in a ratio. So the numerator always has whatever the length of the drawing or the model is, and then the denominator always has what it would be in the real world. Scale drawing is a drawing that is used to represent an object that is too large or too small to be drawn at actual size. So maps are examples of scale drawings. That is probably the most common example. And then finally, a scale model is a model used to represent an object that is too large or too small to be built at actual size. So for instance, a toy car is an example of a scale model. So let's look at our first example. A model car is 4 inches long. The actual car is 12 feet long. What is the scale of the model? So just so we're clear, the scale, this question is asking you to find what 1 inch corresponds to in the real world. So whatever your scale is, you're going to start with 1 inch equals, and then whatever it's going to be in the real world. So you want to set up a proportion. The first ratio is always your scale. 1 inch is equal to some number of feet. We don't know how many feet it is, so we're going to try to figure that out now. We are given 4 inches in the problem is the same as saying 12 feet in the real world. So we're given 4 inches to 12 feet. All right, and now in order to solve this proportion, you would solve it as you would any other proportion. You would cross multiply and solve. So 1 times 12 gets you 12, and make that equal to 4x. So if 12 is equal to 4x, divide both sides by 4, and you end up getting 3 is equal to x. So then your scale would be 1 inch is equal to 3 feet. Now this question just asked for the scale. If it asked you for the scale factor, you would make that into a ratio, 1 over 3, 1 inch over 3 feet. All right, the next example that we have is a map has a scale of 1 inch is equal to 8 miles. Two towns are 3.25 inches apart on the map. What is the actual distance between the two towns? So first you want to set up a proportion. The first ratio should always be the scale. And here is a scale. We're given the scale right there, so the first ratio is my scale, 1 inch to 8 miles. The numerator of each ratio should be the length of the scale or the drawing model. So in other words, 1 inch is the numerator because that's on the scale, or that's on the model, I should say, and 3.25 is also in your numerator. So you have 1 inch over 8 is equal to 3.25 inches over x miles. And then you would just cross multiply and solve as usual. So 1 times x is equal to 8 times 3.25. You end up getting x is equal to 26. So that means that the actual distance between the two towns is 26 miles. All right, let's look at the next example. A scooter is 3.5 feet long. Find the length of a scale model of the scooter if the scale is 1 inch is equal to 3/4 feet. So again, you're going to set up a proportion where the first ratio is going to be the scale. So the scale is given to you in the problem. It says the scale is 1 inch is equal to 3/4 feet. That is your first ratio. So 1 inch over 3/4 feet is equal to, now we're looking to see the numbers that we're looking to find the number of inches, so we're going to call that x inches, and then we know 3.5 feet. So if the scooter is 3.5 feet long, your job is to figure out how many inches that would be in the scale model. So cross multiply and solve. So you have 3.5 is equal to 3/4 x. In order to get rid of that 3/4, right, you have to multiply by the reciprocal, and you end up getting 4 2/3 is x, which means that the length of the scale model is 4 2/3 inches. All right, moving on. Your next example is Sheila is designing a patio that is 16 feet long and 14 feet wide. What would the dimensions of a scale drawing be if the scale is 0.5 inches is equal to 4 feet? So again, you're setting up a proportion. In this case is asking for the dimensions. Okay, so you actually need to set up two proportions, one for the length and one for the width. So the first ratio of each is always your scale. The scale is 0.5 over 4. And next we need to figure out which is our unknown. So what would the dimensions of the scale drawing be? So we're looking for the numerator. So we have x inches over 16 feet. That would be for the length. And for the width, we have x inches over 14 feet. And now you would cross multiply and solve. So I'm first going to go through cross multiplying and solving for the length. So we have 0.5 times 16 is equal to 4x. That means that 8 is equal to 4x, which means that you end up getting 2 is equal to x. So your length would be 2 inches. Your width, you would cross multiply and get 0.5 times 14 is equal to 4x. The left side, when you start to solve it, you get 7 is equal to 4x. Divide both sides by 4, and you end up getting 1.75 is equal to x. So your final answer is, on the scale drawing, the length would be 2 inches, and the width would be 1.75 inches. Alright, so just some concluding thoughts. This is really important, the way that you set up your proportion. You get your entire problem wrong if you don't set up your proportion correctly. So I would suggest that you set up your proportions the same way every time, where the first ratio is your scale, and the numerator of each ratio has to do with the scale drawing of the model, and the denominator is what the length is in the real world. Alright, I hope you learned about scale drawings and models. Thank you for watching.